I would like to throw some light on the reaction mechanism. After completing the basic concepts about the organic reaction mechanism, then I will be able to continue with the hypochrome nomenclature. Is it okay for you?
Okay, sir.
Right. Now, first of all, in organic chemistry, you have got a chemical reaction. What is the difference between a chemical reaction and a physical reaction? In physical reaction, you have got intermolecular force of attraction, right? And that is why it has got some fixed shape. For
Yes, sir.
example, solid has got fixed shape and size. Liquid has got size, but it doesn't have a definite shape. Whereas a gas, it has neither shape nor fixed size, right? So it is
Yes.
because of the intermolecular force of attraction that is different in different states of matter, like solid, liquid, gas. In the case of solid, the intermolecular force of attraction is more, whereas in the case of a gas, it is the least, and that is why they diffuse, and that is why they don't have fixed shape and size. Whereas in the case of solid, it has got fixed shape and size because the intermolecular force of attraction is more. Intermolecular force of attraction is nothing but the attractive force. That is a kind of cohesive force. Is also called van der Waals force. Okay, it's called van der Waals force. Now, when this kind of intermolecular force of attraction is broken, it leads to physical properties. For example, physical reaction. For example, when you melt ice, it becomes water, it becomes liquid by breaking the bond between the molecules. Do you understand this? Okay. Are you following?
So yes, sir.
Right. So when it is broken, it is said the solid is molten. And when you take the chalk piece, cut into two pieces, break into two pieces, and make it as a powder, there arises once again the physical breaking only. So that is, we are breaking the physical bond only. And it leads to physical properties like crushing, crushability, and crystallinity, then a boiling point, melting point, etc. Viscosity, all these things. But in the case of chemical properties like reaction with acid, reaction with the base, oxidation, reduction, all these things, they are all called chemical reaction, where we are not breaking the physical bond, that is intermolecular force of attraction. So we are not breaking that intermolecular force of attraction. Rather, we are breaking. We should not use the word breaking. We have to use the word cleavage, cleaving the bond. So we are cleaving the chemical bond. So it means by cleaving the chemical bond, you are able to produce a new type of chemical bond. Is it not so? Chemical reaction is nothing but cleavage of old chemical bond and formation of a new chemical bond. Do you understand this? And this cleavage of bond is called
Yes,
lysis.
sir.
Lysis means that is fission. For example, cleavage. And in any reaction, when I say chemical reaction, how to represent a chemical reaction, you will put A plus B gives C plus D. And gives means that is indicated by the arrow mark that indicates the reaction condition. Is it not? And sometimes it takes some intermediate state also. So look at this. For example, you have got some substrate and that is going to react with another substrate and that is called reagent. So these two are reactants. So on the left side of the chemical equation, you have got substrate and reagent. So together they are called the reactants. And you put an arrow mark that indicates the reaction condition. Suppose when you put a triangle above the arrow mark, then it is said to be heated. So we are heating the reaction like that. So sometimes in between you will put some transition state also. It indicates there is a transition complex. There is an intermediate state like that. And finally you are able to get product and the byproduct. There will be main product and additionally you will be having some byproduct. So yeah, chemical reaction essentially consists of substrate, reagent, a reaction condition, then products, main products and byproducts, etc. Okay. Now, how, as I already mentioned, the lysis is nothing but cleavage of a chemical bond. So when you talk about the bond, you have got various types of bond like covalent bond, coordinate bond, ionic bond, metallic bond, etc. So let us not confuse too much with this type of bond, but let me say simply chemical bond. So in the case of a symmetric splitting, when a symmetric splitting takes place, it results homolysis and they give the product free radicals. So the free radicals are the products of homolysis, which is nothing but the symmetric splitting. Do you understand this? For example, let me consider this ethane. This is called ethane molecule. CH3 bond CH3. Here, the cleavage takes place evenly and that results CH3 dot CH3 dot. So they are called free radicals. So do you understand this? So free radicals are nothing but atom with odd electron. They are very active. Okay, so very excited, energized, you can say. And similarly, you can have unsymmetrical splitting of a chemical bond also. That is called heterolysis. Here, the ions are the products. Ions are the products means that is one is lost, one has lost the electron, another entity has gained the electron. So that is called anion, and this one, the previous one, is called cation. So here ions are the products. So likewise, homolysis is also called homolytic cleavage of chemical bond. So usually the bond breaking is indicated by a single hooked arrow like this. And it indicates one electron is transferred here, another electron is transferred here, like that. Okay. But so likewise, you've got various types of free radical. Now we have got methyl free radical, and in this case, that is the tertiary methyl radical, secondary methyl radical, primary methyl radical. I mean primary alkyl radical and methyl radical, etc. So are you able to understand that these different structures of radicals here? For example, methyl means you have got methane. What is the formula of methane? CH4. So when C and H, that bond is cleaved homolytically, then it results H dot CH3 dot. So this CH3 dot represents methyl radical. So similarly, you have ethyl radical. Similarly, you have, that is, this is called isopropyl radical. Why propyl? Because there are three carbon atoms and it is branched evenly. So it is called iso. And the carbon atom having, I mean, it has got three carbon atoms. So it is an alkyl radical having three carbon atoms. So it is called isopropyl radical. Do you understand? And
Sir,
what about
sir,
this? Ah, tell me.
I didn't get the dot, the one you said, the
Why we are able to get dot means, so for example, a bond is nothing but an arrangement between two electrons. It is an orbital overlapping. It involves two electrons essentially. So each and every chemical bond involves two electrons. Do you agree with me that?
yes, sir.
So when a bond is cleaved evenly means one electron will go this side, another electron will go that side. So it indicates, this single hooked arrow indicates the transfer of one electron, right?
Yes, sir.
So that is why it results a CH3 dot. CH3 dot means it is an entity or group of atoms or an atom with odd electron. Got it?
Okay, so it has one electron less.
Yes, one electron. No, no, no. One electron it has got additionally.
Okay, okay.
In the sense, for example, you have got a carbon. No.
Yes, sir.
What is the valence of carbon? 4.
4.
So 3 are bound and 1 is left. So it is available with odd electron, right?
Okay.
And that is why it is energized. And that's why it's called free radical. So it can react with any other and similar entity. Got it?
Okay, sir.
That is why the free radical is nothing but the any group of atom or atom with the odd electron. That is one electron not assigned. It is ready to interact with a similar entity. Okay, so that is why it's called free radical, right?
Yes, sir.
Okay. Ions are something different. Ions, I'll explain about this under heterolysis. Now let me finish this free radical. Okay. Right. So now you have got two free radicals, methyl radical, methyl radical. So again, they can fuse together to form methane. For example, when you have got another chlorine radical, it will combine with the chlorine radical to form methyl chloride. Okay. Right.
Yes. Yes, sir.
So similarly, it goes on. So such type of free radicals are very sensitive to photons, that is light, and that is why the you would have studied about the photochemical halogenation of alkane, where the alkanes are subjected to halogenation in presence of sunlight, so that what is the molecular formula of methane? CH4, is it not?
Yes, sir.
And when it is treated with the chlorine, that is Cl2, the Cl2 is cleaved as a Cl free radical. Okay. And similarly, CH4 is also cleaved as a free radical. And these two, they can combine to form what? CH3, Cl. Okay.
Cl.
Chloromethane. Then it can form
Yes.
another hydrogen is replaced. So you are able to get CH2, Cl2. What do you call it?
CH2
Methylene
Cl.
dichloride. That is called methylene dichloride, or you can call it dichloromethane. Got it? Dichloromethane. Okay.
Yes, sir.
CH2Cl2. You can make a note of it. Then again you are removing one more chlorine. So it gives what? CHCl3. This CHCl3 is nothing but chloroform. That is trichloromethane. Okay. Trichloromethane. And this trichloromethane is nothing but the chloroform. Okay. So this chloroform is used as dash. Do you know?
Chloroform is used for I think for
It is
water.
is used in anesthesia, is it not? Okay.
Okay.
Right. And now when you replace another chlorine, what will happen? It results CCl4, right? That is called carbon
CCl.
tetrachloride.
Carbon
That is,
tetrachloride.
yes, that is one of the beautiful solvents used in paint industries and wax industries and polish industries. Okay, right. Now, see, all these chlorine replacement, I mean, hydrogen replacement by chlorine have been taking place by the free radical substitution mechanism. Okay, so this is called photochemical halogenation. Since photons are responsible for initiating this kind of free radical mechanism, chain reactions. Okay, so that is why it is undergoing, we can say it is undergoing free radical substitution reaction in presence of photon, in presence of light, and that is why they are called photochemical halogenation. So do you understand this? Okay.
Yes, sir.
Right. So these are all taking place based on the homolytic cleavage that resulted free radical. And we discussed the different types of free radical. Okay. Right. So when you talk about the stability of the free radical, okay. So here the tertiary, this is called tertiary because thrice branched. And how many carbon atoms
Thrice.
are there? Four carbon atoms. So four carbon atom means butyl, right? So in IUPAC nomenclature, we already discussed about this. Okay. And what about this one? This is secondary, CH3 twice CH. And this is primary, CH3 CH. And this is simply methyl. So when you analyze the stability of this free radical of different types of alkyl group, the tertiary is the most stable one because of the bulkiness. It can achieve the comfortable, that is geometry, so that this is more stable. And this is less stable, and this is less stable, and this is the least stable, right? Now, let me move
Yes.
to heterolytic cleavage. So, what is heterolytic cleavage? Heterolytic cleavage, when a covalent bond is broken or cleaved, there is a difference in the breaking and the cleaving. Cleaving means you can, suppose you take a paper, you can cleave that paper, you can tab that paper, right? You will not break that paper because it's soft. So bond is such a soft one, so we cannot use the word breaking. Instead, you can call it cleaving. Okay. So anyway, for a better understanding or for common understanding, you can use the word breaking. So the bond breaking. You should not feel that the bond breaking is not it's not like breaking a chalk piece, It is something bond, first of all, it is something like an overlapping between two electrons, respective orbitals only. Okay, right. So heterolytic cleavage here, the bond, covalent bond is divided. unsymmetrically, that is unevenly. Okay. So it means two electrons, you know very well for a bond, the two electrons are required. And now, because of the difference in the electronegativity, this pair of electron is totally withdrawn by the more electronegative atom, like in the case of bromo butane. Here, bromine atom is a more electronegative than carbon. So bromine has the electron negative character, more electronegative character, and that's why it abstracts the electron of carbon also. Do you understand? And thereby it gets one more electron, so it becomes a B or minus. So when it is divided, you can see in the previous case it was evenly broken. In this case, it is unevenly broken. It means the bromine has taken the electron of carbon also, right? And that is why it becomes a B or minus. So negative ion is called anion. And what about this one? This is tertiary butyl cation. Okay. So heterolytic cleavage where electron transfer takes place, right? And that is indicated by a double hooked arrow. Or able to follow? So here you have used a single hooked arrow that indicates the transfer of one electron from the shared pair. Okay. Whereas in this case, we have represented the transfer of two electrons by what? We have double hooked arrow like this. A
Double bond
normal, yeah, normal
arrow.
curve, curved arrow like this. Okay. So this bromine has taken the electron of carbon also, and that's why it has become B or minus. And this has lost one electron, so this becomes cation, right? So this is cation, this is anion. Okay. So you can say the ions are the products of electrolysis. You understand this? And what about free radicals? They are the products of homolysis.
Products.
Okay.
Yes.
Right. So this carbon can also be called with having plus can be called carbocation or carbonium ion. All the positive ions are normally suffixed by IUM. For example, sodium, potassium, okay, strontium. Okay, almost all metals they have the positive character and they are called IUM only. For example, even ammonium NH4 plus, right? Sodium Na plus. Similarly, the carbon or its a group of atoms along with the carbon can be called carbonium ion or carbocation. Okay. Now, this carbocation where the nucleophiles can attack, and the carb anion means carbon with its electron. So when it is having negative charge, then it is called carb anions where the electrophiles attack. Excuse me. And you should know what is electrophile and what is nucleophile. Philo means to attract. Nucleophile means a nucleophilic reagent. That is the reagent that attacks the carbocation or carbonium ion. So if it attacks a carbonium ion, a positive ion, a nucleus, then it should be having negative charge. Is it not? So the
Yes.
nucleophilic reagent is nothing but a negative ion that goes in search of what? Positive ion. Do you understand this? Okay. So that is why we call it nucleophile. Nucleophile means nucleophilo. Philo means to attract. So it goes in search of nucleus. That is carbonium. Okay. So in that case, it can be, for example, Br minus, OH minus. These are all nucleophiles. Please take down nucleophiles. Okay. Then electrophiles means just opposite. They attack the electron rich center, electrophilo, electrophiles. That is electron searching group. Who will be searching for electron? The one which is
And
deficient of electron, otherwise positive.
yes, scatter.
So electron deficient group or a positive ion can be called electrophile because they go in search of what? Electrons. So it should be a positive one. So positive ions are called electrophiles. And for example, nitronium ion, okay, NO2 plus nitronium ion, okay, right. So I hope now I am able to explain to you about the what the different types of chemical reaction, that is homolysis and heterolysis, and what are their respective products. Now, under chemical reactions, we'll be discussing substitution reaction, addition reaction, elimination reaction, then condensation reaction. Substitution reaction can also be called replacement, just replaces, as in the case of free radical mechanism, that is photochemical halogenation, where we have seen the methane, the four hydrogens are one by one replaced by chlorine. In the first case, methane is methane. First case, methyl chloride, that is chloromethane. Second, dichloromethane. Third, trichloromethane. Fourth, tetrachloromethane. So likewise, one by one, the hydrogen is replaced, and that is carried out by what the free radical mechanism, and that is why this is called free radical substitution reaction. Do you understand? And when the
Yes.
substitution reaction is triggered by electrophilic attack, then it's called electrophilic substitution. Similarly, there is a nucleophilic substitution that is triggered by nucleophilic attack, and where it has got two types. One is nucleophilic substitution first order, nucleophilic substitution second order. We have got internal nucleophilic substitution also, but it is out of your scope. And let us confine to SN1 and SN2 mechanisms. Okay. So under nucleophilic substitution, we will be discussing nucleophilic substitution first order reaction, nucleophilic substitution second order reaction. Okay. Right. Then addition reaction. So wherever you have got
So,
double bond,
uh,
yes, tell me.
isn't there a thing that in substitution only occurs in like alkanes, like the
Uh,
saturated compound?
yes, saturated compounds. So
So
in
it
all
cannot
cases, this
happen
kind,
in unsaturated.
yeah, that is no. The substitution is a predominant in the case of alkanes, and in case
Okay.
of alkenes, addition reactions take place, and also in alkynes. So wherever you
Okay.
have got unsaturation, unsaturation means the presence of double bond or triple bond, CC double bond or CC triple bond. So where you can have this type of addition reaction, and when it how it is sourced, how it is triggered. So based on that, the mechanism is provided here. So addition occurs across the double bond only, right?
Yes, sir.
So across the double bond means in a double bond you have got carbon-carbon double bond, you have got one single bond, that is sigma bond, and one pi bond. So this pi bond is weaker than sigma bond. Sigma bond is formed due to linear overlapping of orbital, that is axial overlapping of orbital. It is stronger because the extent of overlapping is more in the case of sigma bonding. Whereas in the case of pi bond, the extent of overlapping less because it is a sidewise overlap, okay, lateral overlapping. So it cannot go beyond certain limit, and that is why it is slightly touches upon each other, and that is why this is weaker. Pi bond is weaker than sigma bond. Do you understand this? And when
Yes.
it is subjected to addition mechanism or addition reaction, the main casualty is a double, I mean sigma bond. Okay, I'm sorry, not sigma bond, pi bond. And not only that, when the double bond is slightly twisted, the immediate casualty is the pipe. So that is broken, and thereby addition. That is, in addition to the existing number of atoms, these hydrogen, halogen, or two halogens or two hydrogen can combine with the C double bond C. So this is called addition reaction. I will explain with a proper example when I study deeply about this. Okay, then. Similarly, you've got electrophilic addition reaction, nucleophilic addition reaction. Then elimination. Elimination means that is one of the atoms will be removed. And this type of reactions are called E1 they have got two mechanisms, E1 mechanism and the E2 mechanism, like in the case of SN1, SN2. So usually these beta protons are removed by the abstracted by the incoming OH minus ion. I will properly explain when I discuss in detail about the elimination reaction. So an existing atom is removed from the substrate, and that is called elimination reaction. So to start with, you should know at least this. Okay. So elimination means what? Removal. So some atom is removed from that, and how it is removed, and that is the mechanism. Okay. Then hydrolysis. Lysis means cleavage of chemical bond, as I already mentioned. We already discussed about homolysis and heterolysis, is it not? And here hydrolysis means lysis, a chemical bond is cleaved by the influence of water. Hydro means water. So it is called hydrolysis. When it is influenced by ammonia, it is called ammonolysis. When it is influenced by some catalyst, it is called catalysis. When it is influenced by, say, some that is ozone, it is called ozonolysis also. Okay. So likewise, here we have got hydrolysis. And then condensation. Condensation is nothing but when a reaction is accompanied by the release of neutral molecules like water or ammonia, then it is called condensation reaction. Okay, so we have got various types of condensation reactions. Then polymerization reaction. Polymerization means you will be having monomer and several units that they combine together to form a giant molecule, and they are called polymers. Okay, when two monomers are combined, they are called monomers. Sorry, dimers. Three monomer means a trimer. Four monomer means tetramer. Likewise, many means a polymer. Okay, and you know much about the redox reaction where you have got de-electronation and electronation, because we know oxidation is nothing but de-electronation and reduction is nothing but electronation. Okay, so the compounds, organic compounds can also undergo such type of redox reactions, right? Then synthesis. Synthesis means that is from the basic molecules, you should be able to get advanced molecules so that we can prepare that synthetic route also from the simple molecules, which is locally available and which is cheaper also. So that kind of laboratory synthesis is called synthetic organic reactions or synthesis. And there are so many named reactions and named synthesis reactions also. Then you have got molecular rearrangement. These molecular rearrangements are very specific, and I can cite one example. There is one type of a molecular rearrangement where when the bond is slightly twisted or rotated, it creates some noise also. So that is a special kind of a molecular rearrangement. And likewise, we have got various molecular arrangement, but that is beyond the scope of your syllabus now. Now, as I already explained, nucleophiles are nothing but nucleophilic reagent, that is negatively charged reagent, and which go in search of positive center or carbonium ion. And what about electrophiles? Electrophilic reagents, which are positively charged reagents, which go in search of electron-rich center or carb anion. You have to say carb anion. So what is carb anion? Electron-rich, that is C minus. What is a carbocation or carbonium ion? C plus. Okay. And we have different types of nucleophiles also. I have listed here. For example, we have got, as I already mentioned, nucleophile. Nucleo means what? Plus, that is positive. Positive research, positive searching reagents means it should be having electron, is it not? So in this case, we have two types of nucleophile. One is neutral molecules having unshared pair of electron because they are electron rich, like in the case of ammonia where you got pair of electrons, and that is accessible, or that is that approaches the posterior because it has got a pair of electron. So electron rich nitrogen. And what about this water? It has also got two pairs of oxygen, I mean electrons on the oxygen. Similarly, in hydrogen sulfide and the thiols, so this is called thiols. Alcohol, ROH is called alcohol. When O is replaced by sulfur, it is called thioalcohol, simply called thiol. Okay. And sulfur is also one of the nucleophilic reagent, that is neutral nucleophile. So these are all neutral nucleophile. But even though they are neutral nucleophile, they are enriched with electron, and that is where they approach the positive center or carbonium ion or carbocation. And negatively charged nucleophile. So this is absolutely negatively charged where chloride, bromide, iodide, halide, etc. Then hydroxide OH minus, alkoxide RO minus, carboxylate anion CO or COO minus, cyanide CN minus, etc. Okay, so these are all the electron, uh, negatively charged nucleophiles. So likewise, what are the two major types of nucleophiles? One is neutral nucleophile, another is negatively charged nucleophile. Do you understand this?
Yes, sir.
Now let me move to the next concept, that is examples of electrophile. What do you mean by electrophile? Electron, that is negative. File, search, going in search of. So electron searching group means it should be basically positive. For example, positively charged electrophile. Carbocation, proton, alkyl halide, oxonium ion, nitrosonium ion, nitronium ion. So these are all having plus ions, and that is why they are called positively charged electrophile. And similar to that of a nucleophile, the electrophiles can also be neutral, but they are electron deficient. And that is why they are called electron deficient entirety. So here you have carbon dioxide, dichlorocarbene, aluminum chloride, boron trifluoride, and ferric chloride, etc. So here the metals are electron deficient, and because of this, they are approaching the what? Electron rich center. That is why they are called electrophile. So do you understand up to this? If there is any doubt, you can ask.
Yes, sir.
Shall I ask you some questions? Okay, ready?
Um. Okay, okay, sir.
Right. What do you call lysis?
What do you call lysis? Lysis is basically cleavage of
Very good. What do you mean by
chemical.
homolysis?
Yes, sir.
What do you mean by homolysis?
Homolysis is basically it's also a cleavage of chemical bond, and basically it is shown by a single hooked arrow where it is divided symmetrically into two different parts.
Very good.
And
Which are the,
yes,
very good. Which are the products of heterolysis?
ions are the products of
Very good.
heterolysis.
What are the products of homolysis?
Free radicals are the
Okay,
products of
good.
homolysis.
And define free radical.
Free radicals are basically the compounds which are fully energized,
Energized and
and they are denoted by, yes, sir.
an atom with odd electron or a group of atoms with odd electron. They are indicated by a
Okay,
dot. Okay. And among these, which is
okay.
the least stable radical? You have got the tertiary, secondary, primary, and methyl. Which is the least stable?
Primary, the
That is methyl radical, right?
methyl.
And among the primary,
Yes,
secondary, tertiary, which is the most stable free radical?
tertiary.
Tertiary. Very good. And see how the homolytic cleavage is represented using the arrow. Single hooked, double hooked.
Homolysis is single, heterolysis is double.
Double, very good. And how this heterolysis takes place, it is because of dash, the difference in dash,
Difference in electronegativity.
difference in electronegativity. Very good. And towards which atom electron is transferred?
Towards the like the like the
Yes, more
negatively
electronegative. Okay, good.
more
And what is the other name for carbocation?
a carbonium ion.
Carbonium ion. Very good. And what are the two types of elimination reaction
Um,
mechanisms?
E1 and E2
E1
mechanism, which
and
is
E2. And what are the three types of substitution reactions?
three types of substitution reaction is halogenation,
No, no, no. Substitution types. Free radical substitution,
free radical electrophilic,
electrophilic substitution, nucleophilic substitution.
nucleophilic
Good.
substitution, which
And
is
what are the two types of nucleophilic substitution?
SN1 and SN2.
What do you mean by SN1?
Um,
Nucleophilic
Sorry, sir.
substitution. It is actually reversed. Nucleophilic substitution, first order.
First order.
And another one,
Okay.
nucleophilic substitution, second order.
Substitution. Second order.
Order means, for example, if you have got two reactants, okay? If you have got two reactants and reaction involves certain reaction, that reactants involve certain reaction. So it involves two molecules like A and B gives C and D. So it has got two reactants, A and B. Molecularity is the number of reactants available for the reaction. So in that case, A plus B gives C plus D means there are two reactants, is it not? So the molecularity is 2, right? Okay.
Yes, sir.
2A
Yes, sir.
plus B gives us some product. What is the molecularity?
Two.
3. Because 2A, 2
Three.
moles, 1B. So 2 plus 1, 3. Good.
Yes.
3A plus 2B. What is the molecularity?
Five. Five.
5. That's good. Now, you know, the molecularity is nothing but the number of moles of reactants involved in the reaction. Got it? You please make a note of it. What is molecularity? The number of moles of reactants involved in the reaction. Finished? Right. Now, order. Order is the number of moles of reactants involved in the reaction. But you may ask me one question. Sir, both are same definition. No, you had to continue. So the number of moles of reactants whose concentration determine the rate of the reaction. That makes the difference between order and molecularity. So what is molecular order? The number of, take down, the number of moles of reactants whose concentration determine the rate of the reaction. So that is very important. That makes the difference between order and molecular. Molecularity is a simply number of moles involved in the in the reaction. As I already mentioned, for example, 3A plus 2B gives some product. So what is the molecularity? You can say immediately 3 plus 2, 5. Right? Now,
Yes.
what is the order? You cannot say order is 5. Before that, you have to ask me one question. Sir, this reaction depends on which reactant. Now let me say, let me disclose, okay, this reaction depends on reactant A only. So in that case, now tell me the order of 3A plus 2B gives product.
3.
Very good, because that decides the rate of the reaction. Okay, I hope now you
Yes.
should be able to understand the difference between order and molecularity. Okay, now let me
Yes.
check. See, the rate of the reaction depends on 50% of A and 50% of B. Now tell me the order of the reaction for 3A plus 2B is equal to product. 3 moles, 50% means what? 1.5, right?
One and a half.
And
So it will be
50% of B, that is half. So 1.5 plus a half results what? 2. So you can declare the order
2.
is 2. Do you understand this?
Yes, sir.
Now let me ask you one more question. The order is dependent on none of the reactants. What is order? The reaction
0.
0. So this is called zero order reaction. I hope now you should be able to understand some basic concepts about the kinetics of the reaction. Kinetics means the speed of the reaction. Okay? That is how fast the reaction takes place. In chemistry, there are two
Yes.
people. One people from thermodynamics, another people are from kinetics. Thermodynamic people, they are always worried about the completion of the reaction. For example, when A reacts with B, for them, they are waiting for the completion of the reaction. They will accept only after the completion of the reaction and they will say the quality is okay. So they are all quality oriented people. But these production guys, they are always very fast, you know. They are very quick to finish the reaction. So in that case, they talk about only the reactants. Okay, so that is why order is very important term associated with the chemical kinetics, right? So in our subsequent courses, we'll be discussing in detail about this chemical kinetics and the thermodynamics in subsequent chapters. Okay, right. So far I was discussing with you regarding the basic concepts about the reaction and mechanism. And here, finally, I was explaining about the examples of nucleophiles. And there are two types of nucleophile. What are those? Negatively charged nucleophile and the neutral nucleophile. And similarly, electrophile, positively charged electrophile and a neutral electrophile. Okay, right? So with this, let
Yes,
me
sir.
conclude this session and we will continue in the next class. And I will explain some more insight on the IUPAC nomenclature also. Okay, right. So you can leave the session, but continue to explore our videos. I will try to link you in this channel so that you can further go through this organic reaction mechanism and take down all the notes also. Okay, right. See you. Bye.
Yes, sir.
Ah,
Sir,
ah.
sir. Actually, I was like, I have an exam as soon as